So in this video, I want to explain the difference between blocking and non-blocking assignments. Both of them are types of procedural assignments or assignments. And we call them procedural because they live within the always statements. So I showed you some guidelines or some rules of thumbs of when to use what. Okay, we usually use blocking with combinational and non-blocking with sequential circuits. But I just wanted to explain to you how they're actually operational. And in order for me to do this, I will explain it using what we call a simulation timing module. So let's assume that you wrote some code and you want to actually simulate it. So a simulator usually create a bunch of time blocks. Okay, so what I have in here is I have time. So according to time, what I'm going to do is I'm going to divide it into little time slots. So this is time slot I minus 1, time slot time slot I plus 1. So the code is going to go through, you can think about it as if the circuit is operating in time, but this is a simulation. It helps me actually explain how these work. Okay, so we're going to take a look at one of these time slots, and what you can see is I have a couple of regions in it. The one region is called active, and the other one called a non-blocking activity regions or activity regions. Okay, so I have basically an activity list in here and activity list in here. Okay, so well, the active is actually just a bunch of things that needs to be done, evaluations that like a summation that needs to be done, a comparison that needs to be done, maybe an assignment. You're assigning something to something else. Non-blocking assignments here, it's actually not active. NBA stands for non-blocking assignments because it can only include assignments, nothing else. You can't compute, you can't do anything. You're just assigning some number to a different variable or whatnot. And I'll explain to you what happens in here with the arrows. So sometimes it's basically there's some sort of feedback loops and whatnot. Okay, usually the input comes from the previous time slot and then you move to the next time slot. Okay, and you have a bunch of activities, and these activities are arranged in a list, and you do them one by one by one, usually sequentially. Okay, and then the non-blocking assignments happens here. So let's see how blocking assignments actually work. So I'll take this particular activity here, or the timing simulation basically model that I have, and I'll just explain it with an example. So let's take a look at this example. So in this example, and I'll go through it slowly, I'm calling it an AND block because it performs a bunch of ANDs. I have 3 inputs, A, B, C, and I have a logic Y. Let's assume that we got to the time slot that we're in, and what happens is the following. So while I have a blocking assignments, which is an immediate assignment, and this here tells me Y equals A. It's called blocking or immediate because you really want whatever is in A to be assigned directly to Y, and you're not going to do anything till this finishes. So you're blocking the execution of whatever happens after this here. Okay, that's what you're doing. So you're going to go in here and you're going to put in the activity list or in the active list here, you can see that Y equals A. That's basically the first activity you're going to have. So the value of Y, I'm just going to keep track of it here. The value of Y is actually A. It actually have that value of Y, of A. Okay, this is part of the activity. Your always statement you might have a bunch of other always statements. This is why we have this particular array in here, because maybe my code includes a couple of other statements, or maybe 3 or 4 always statements, or even continuous assignment for that matter. You might have something else in here actually as a continuous assignment. They'll all be here within this active region, all of them. And they're all going to be basically squeezed into this array in here. Like I'll have a bunch of things to be doing. For simplicity, I'll just focus on this particular code, but I just want you to know what the active list have. So the active list just have those, whatever it has, like it has a bunch of them because they're all concurrent, so they're all there. And there's nothing that is more important than the other. There's nothing in the Verilog standard that tells me this combinational circuit was written first, so it has to be executed first. It might have that these other always statements are actually executed later. Like there's nothing to the order, okay? Okay. Good. So now I know that Y equals A because it's part of the active here. Okay. And sometimes I just want to explain now what happens. Why do I have this particular feedback loop? Can an active actually generate another activities? And the answer is yes. Because let's assume that particular Y equals A. What happens is you change Y, and let's assume that Y is an input for this particular always statement. Because it's an input for this particular statement, you basically triggered the activity for this always. You're actually doing something and you're actually scheduling more activities in here while you're executing it. So this is the purpose, and this is the reason why we have a feedback, because a change in one of these activities might trigger another always, or might trigger another activity. Maybe you're triggering a continuous assignment for all that matters. You're triggering something. That's the idea. Okay, so let's assume here, well, we didn't finish, so let's finish. We're going to get to the non-blocking assignment once we finish, basically, or we're never going to get it here because we have only blocking assignments. We don't have a non-blocking assignments. So let me show you what happens after for the second one. So I know that y equals a. Now what I have in here is y equals y and b. Well, technically y will have a and b because y already have a in it. So it will go in here and it will basically schedule y and b. And again, this particular statement, which is y equals a, will be executed definitely before the second one because I'm using blocking assignments or immediate assignment. You're immediately assigning a to a. You're blocking everything afterwards. Okay, the same goes in here. You're immediately assigning y, the value y and b, but y already have the value of a, so you're basically assigning it a plus b, and you're blocking everything afterwards. Nothing is going to happen until this assignment is immediately assigned and blocked, okay, or finished. All right, so next what happens is, you're going to see in the next blocking assignment in here is y and, well, it's and c. Basically, I'm doing that. And you can see at the very end here, of course, it's going to go here and say y and c. You can see at the very end now, I'm basically done with this module. Nothing is happening, but the value of y is a and b and c, like I expect it to be. Nothing goes to the non-blocking assignment because I did not have any non-blocking assignments. All of these are blocking or immediate assignments. Okay, so what happens is we move to the next time slot. So you move in here, this is the value of y, and you move to the next time slot and you do the activities again and again and again. So let's see how this actually translates if I change all these blocking assignments to non-blocking assignments. It's the same code. Let's see what actually happens. All right, so again, remember, I might have other always statements. I might have continuous assignments in here. The continuous assignment doesn't have to be here. It can be anywhere, okay? Well, within the end module, like it has to be within the module, but still. All right, so, okay, so let's see what happens in here. So what happens in here is I'm saying, okay, y is non-blocking assignment or a deferred assignment to a. So I'm going to track the value of y, and the value of y did not change. So non-blocking assignment actually does not change the value of y. What it does is it schedules it. What happens is, well, I'm telling it in the non-blocking assignment, I want you to put y, I want you to put the value a in it. That's what I want you to do, but later, once I'm done with all the activities here in the active list here. Once I'm done, we're going to do these non-blocking assignments at the very end of that module. Okay, so, well, y, now I'm assigning a. Okay, next, what is it doing? And before I do the next here, it effectively, what it happens in here, really literally, like let's assume that I have something in here else, and let's assume that else is x plus 3 plus 6, whatever it is. What happens is this particular expression gets evaluated here, x plus 3 plus 6, okay? You evaluated whatever that value is, you later assign it to y. Okay, so what I'm trying to tell you is the active list gets whatever is on the right hand side, but it does not assign it to the left hand side yet. It just leaves it till the end. This is why it's called a deferred assignment or a non-blocking assignment, because it doesn't block the execution of what happens next. At the same time that y, you schedule y to be equal to a. At the same time, what you're doing is you're saying, well, I want to evaluate y and b, and I will, and then later I'll evaluate it to y. So, okay, so you're evaluating still, remember, it's like I'm tracking the y in here. Nothing is changing yet. Nothing changed. So I'm evaluating y and b. Whatever the value is in y is, I'm just basically ending it with b. I'm trying to figure out what that value is, okay? And I will figure it out, and then I'm going to say, okay, because it's a non-blocking assignment, what I'm really doing is I'll schedule it later. I'll assign it to y later. And because I already have that scheduled, well, what happens, I'm overwriting it now, and I'm going to say, well, it has to be a y plus and b. Of course, I have already figured out what that value is, supposedly, because I evaluated it. So you evaluate whatever is on the right hand side, and then you later assign it. Okay, so we go to the last element in here, and that last item is basically y and c. It's very similar to the y and b, so I'm going to do it in here. And again, it goes and overwrites this, like it evaluates what y and c is, evaluates it, then gets in here and say y and c. And that's basically what's scheduled. So it overwrote whatever we did here and here. It overwrote them, okay, because it kept scheduling what y is, what y is, what y is. So it's only doing the last item. All right, so now that everything is done, okay, we go to the non-blocking assignment. But before so we go to the non-blocking assignment because I'm technically done. I'm at the very end. So I'm going to go to the non-blocking assignment, and non-blocking assignment tells me, well, the value of y should be equal to y and c. That's basically the value at the very end. But guess what? What happened is you changed y, okay? You just changed y within this time block. What happened is it's actually going back in here and triggering, because you just re-triggered that continue, like that always block. You triggered it again because it has that y here, because the y is an input here. So you triggered it so that it will calculate it again, and that's the reason why we have that particular one in here. It could be for something more valid, but anyway, you get the idea. Let's assume that everything is done and this is what I have in here. What I want you to do is I want to show you what actually gets evaluated. So y, which is my output, is actually just the output of some sort of an AND gate. And the AND gate takes a C as an input and takes a Y as an input. Interesting, huh? Something to keep in mind. So hopefully you guys get the idea that this is not a combinational circuit anymore. It's actually, since you have a feedback loop from the output to the input, you basically are dealing with sequential circuit. So this is absolutely wrong, and you will get some sort of a warning saying that. And this is why this actually violates the rule that I told you. Only use always comp with blocking assignment. What we did here is use always comp with a non-blocking assignment. Non-blocking assignment should be reserved for sequential circuits only. Okay, that's what you should reserve it to. So this is how on a blocking and non-blocking assignments. I'd rather think about them as an immediate assignment versus a deferred assignment. So some people would think about it like, okay, maybe you can definitely use a non-blocking assignment in a combination, but you're going to confuse yourself, and it's generally very confusing in Verilog. This is one of the most confusing thing in Verilog and system Verilog. So stick to the ideas, and hopefully everything will work.